Hello, my name is Andrzej Cimiński and I'm application engineer at Keysight Technologies EEsof EDA. I'm here at ECOC 2017 to talk about the PAM-4 simulation for analysis high-speed digital links. As people use more apps on their telephones, smartphones, computers, tablets, and IoT devices, the network needed to deliver the data is constantly being upgraded. PAM-4, which is 4-level pulse amplitude modulation, is a leading choice for implementing 56 gigs LAN data rate, which will, and actually right now it's doing that, enables 400 gigs data lengths, and also allow to next upgrade in the network bandwidth. Doubling the data rate with traditional NRZ, non-return to zero, is technically challenging, and that's due to the high losses at the high frequencies. PAM-4 is alternative solution and transmit at 28 gigabaud with 4 amplitude levels, where each level indicates or represents 2 bits. And that's deliver 56 gigabit per second throughput. Advanced Design System Channel Simulator with PAM-4 capabilities features number built-in mechanism and measurements that can capture a lot of different effects. So let's look at some demo. This is an example of a channel simulator. This is an electrical channel that is represented by S parameters. We can look at the inside, how the S parameter goes, and as you can see, we have a lot of attenuation at higher frequencies. The driver itself is modeled by IBIS-AMI, and this is a real circuit with modulation specified as PAM-4. And as well at the receiver side, we also choose the PAM-4 as modulation. On top of that, we have also other parameters that are suitable for different type of equalization. Channel simulator controller is set to simulate 1 million bits with bit-by-bit mode. On the end output of the receiver, we have the iProbe, which is our measurement controller, actually measuring the stuffs. And the selected measurements are depicted on the right-hand side column. When hit to simulate, we'll get the simulation results depicted on this picture. So in the middle we have the PAM-4 eye diagram with the 3 slices. On the right-hand side, these are the actually symbol rate contours. On the right-hand side, we have as well upper threshold, lower threshold, in center threshold selected. Beneath there is a bathtub, and as well some table for measurements. Obviously, there are a little bit more measurements available from the iProbe itself and the simulation that channel simulating provides. So whenever needed, can be picked up anytime. Another demonstration represents the similar situation, although right now, instead of electrical channel, we have the optical channel modeled also by the IBIS-AMI model. This model has been developed and generated from the electric system level software called System View. And as you can see on the top AMI, there are 2 columns right now, input parameter list and as well output parameter list. In the input parameter list, we have all the parameters where our optical channel is described of. So we can choose which of the parameters would like to discover or sweep or scan, or maybe as well can run a batch simulation. In this particular case, we pick up the bias of the vertical cavity surface emitted laser, and we're going to scan this from 3 milliamperes and stop at 9 milliamperes with the step 0.5. The same schematic has been done also with PAM-4 excitation and as well NRZ excitation. So right now, having those two results available, we can compare PAM-4 and NRZ, which one of the modulation is better from which level of the bias of the laser. So changing the marker, we can see how the simulations results are also changing, and pick the one which is most representing for the given parameters and as well given simulation spec. And third demo is about the optical channel itself, which, as was mentioned, is represented by IBIS-AMI model. So how this model has been generated. As mentioned before, system view, which is the system simulation level software, can generate also IBIS-AMI models. So at this simulation chain, we have the PAM-4 transmitter. We have the optical links, which is represented by the models inside as well. So let's open it up. So from the left to the right, we have also, models like laser driver, laser model itself, some multimode fiber models with the different parameters, detector, and so on. And this can be modeled with the different other components as well, for instance, system view. And once the modeling is done, we can verify the signal by connecting the outputs from different points to the Flex DCA sync, and that sync will automatically show up the results. The important thing is that Flex DCA software is a software that also runs on our scopes. So you're verifying the quality of the signal with the same algorithms, with the same software, both on the computer or on the scope. So once we are done with modeling, you can open up the code generation option and choose the target. Like in this case, it's IBIS-AMI algorithm modeling interface. And when all the parameters are set properly, click Generate Now button, and the IBIS-AMI model will be generated. Keysight Technologies with Advanced Design System environment, especially Channel Simulator, provides trusted bit-by-bit simulation engine for PAM-4 signaling. For more information, please visit our webpage keysight.com/find/PAM-4. Thank you for watching.